On the homework problem, you were starting with 49 meters per second. They didn't say anything about rounding, so I'm going to say this is like negative 9.8 meters per second squared. If I start at 49, then that tells me that I'm going to stop in how much? How many seconds? Negative 9.8 equals 0 minus 49 over time. So swap these. Time is going to be 5 seconds. Then at 5, it's going to be 0. And right here, I can mark 49, or it's probably 50. I might make it 50 and just start very close to 50, and that's my straight line right here. That would represent velocity in meters per second versus time. If it starts at 49 meters per second, v final squared equals v initial squared plus 2 acceleration x. So this is what I'm after. My maximum height, so 0, my maximum height, so negative 49 squared divided by 19.6. And remember that 19.6 is negative because 9.8 is negative. That ends up with 122 and a half. And I know that the top is going to be reached at 5 seconds. Now let's calculate everything else. 49 times 1 minus 4.9, that is v times t. That is plus 1/2 of negative 9.8, and then times t squared, that's 1. 41 minus 4.9, so 36, this is going to be 30, that's 35, so it's going to be somewhere right here, just approximate like that. Then at 2 seconds, that's 49 times 2 minus 4.9 times 4, because that's 2 squared. Gets me 21.6, so it's almost 22. Now, what is our position when the time is 3 seconds and 7 seconds? 49 times 3 minus 4.9 times 9. That's 93.9, almost 94. Almost 94. So I know this is 90, that's 95. So somewhere down like so. By 3 seconds and by 7 seconds. There we go. And then finally, at 4 seconds and at 6 seconds, our two matching points. 49 times 4 minus 4.9 times 16. 117.6. That's 120. 117.6 is almost 120. Not quite. So something like that. So overall, but that is the shape of something that has been tossed. It will look like a parabola. It will look like a flat line for acceleration, a sloped line where the slope is that acceleration, the value of that acceleration, and then as for position versus time, that would be a parabola. If we toss something upward, it's going to have a full parabola with the peak at the maximum height in half the time, because it's going to stop at half the time and reach its maximum height, and then it's going to fall down. But if you just drop something, that's exactly half of this parabola, only this right there. This goes away. Okay? See you in class.